Hello students, in Science 1, let us revise Chapter 11, Reflection of Light, and Chapter 12, Study of Sound. What is light? Light is the form of electromagnetic radiation which causes a sensation of vision. What is meant by reflection of light? Which are the different types of reflection? When light is incident on the surface of an object, it gets deflected in different directions. This process is called reflection of light. Reflection of light from smooth, flat surfaces is called regular reflection, while that reflected from rough surfaces is called irregular reflection. What is a mirror? A surface which reflects light and creates clear images is called a mirror. It is also known as a reflecting surface. What are the various types of mirrors? Mirrors are of two types, namely plane mirrors and spherical mirrors. How is a plane mirror made? Who made the first mirror and how? A plane mirror is made by coating the back surface of a flat and smooth glass piece with a thin reflecting film of aluminium or silver. To protect this reflecting film and to make that side opaque, another coat of a substance like lead oxide is given over it. The German scientist Justus von Liebig made the first mirror by coating the plane surface of a piece of ordinary glass with silver metal. Such a mirror is called a silvered glass mirror. State the characteristics of the image formed by a plane mirror. The image formed by a plane mirror is virtual, erect or upright and of the same size as that of the object. There is lateral inversion, which means that the left side and the right side are interchanged. The image formed behind the mirror is at the same distance from the mirror as the object is in front of the mirror. State the laws of reflection of light. Laws of reflection for light reflecting from a smooth surface are as follows. The incident ray and the reflected ray of light are on the opposite sides of the normal to the reflecting surface at the point of incidence, and all the three lie in the same plane. The angle of incidence is equal to the angle of reflection. How is an image formed by a point source of light? Light rays travel in all directions from such a source. Several of these rays fall on the mirror, get reflected and reach our eyes. Due to reflection, they appear to be coming from a point behind the mirror. That point is the image of the point source. When light rays fall perpendicularly on the mirror, they are reflected back in the perpendicular direction as seen in the figure. When a point source, that is object O, is placed in front of the plane mirror M1, M2, incident ray OR1 and OR2 get reflected according to the laws of reflection along paths R1S1 and R2S2 respectively. When these reflected rays are extended behind the mirror, they meet at O1. When seen from E, the rays appear to be coming from O1. Other rays starting from O also get reflected and appear to be coming from O1. Thus point O1 is the image of point O. The reflected rays do not actually meet, hence such an image is called a virtual image. The perpendicular distance of the image from the mirror is equal to the perpendicular distance of the source from the mirror. If we use an extended source instead of a point source, an image is formed of every point source, thereby forming an extended image of the whole source. As shown in figure C, an extended source PQ is kept in front of the mirror M1, M2. The images of P and Q are formed at P1 and Q1 respectively. Similarly, images of all points between P and Q are formed between P1 and Q1, resulting in the image P1, Q1 of the entire extended source. The image formed by a plane mirror is of the same size as the source. Statement: in order to see the full image of a person standing in front of a mirror, the minimum height of the mirror must be half the height of the person. Proof: in the figure, the point at the top of the head, the eyes, and a point at the feet of a person are indicated by H, E, and F respectively. R and S are midpoints of HE and EF respectively. The mirror PQ is at a height of NQ from the ground and is perpendicular to it. PQ is the minimum height of the mirror in order to obtain the full image of the person. For this, RP and SQ must be perpendicular to the mirror. Minimum height of the mirror PQ is equal to RS, that is equal to RE plus ES, that is equal to HE upon 2 plus EF upon 2, and that is equal to HF upon 2, because RE is equal to half of HE and ES is equal to half of EF. This is equal to HF upon 2, which is equal to half of the person's height. Spherical mirrors. There are two types of spherical mirrors: concave mirror and convex mirror. Concave mirror. If the inner surface of the spherical mirror is the reflecting surface, then it is called a concave mirror. It is a converging mirror. Convex mirror. If the outer surface of the spherical mirror is a reflecting surface, then it is called a convex mirror. It is a dispersing or diverging mirror. Explain the difference between a plane mirror, a concave mirror, and a convex mirror with respect to the type and size of the images produced. With respect to the type and size of the image, a plane mirror produces a virtual, upright, or erect image which is of the same size as that of the object. The image produced by a concave mirror depends upon the distance between the object and the mirror. The image so formed is real or virtual, inverted or erect, smaller than the object or larger than the object, or of the same size as that of the object. The image formed by a convex mirror is virtual, erect, and smaller than the object. If a spherical mirror breaks, what type of mirrors are the individual pieces? If a spherical mirror breaks, the individual pieces will still be of the same type as the original concave or convex mirror. The nature of the reflecting surface and its radius of curvature remains unchanged. Three mirrors are created from a single sphere. Which of the following: pole, center of curvature, radius of curvature, principal axis, will be common to them, and which will not be common? Since all the three mirrors are derived from the same sphere, they all have a common radius of curvature and a common center of curvature. But the pole and the principal axis will not be common. What is mirror formula? We get the correct values of distances by using the Cartesian sign convention. The object distance u is the distance of the object from the pole, while the image distance v is the distance of the image from the pole. The relationship between the object distance, image distance, and the focal length f is called the mirror formula. 1 upon v plus 1 upon u is equal to 1 upon f. This formula is valid for all spherical mirrors for all positions of objects under all circumstances. What is meant by magnification produced in spherical mirrors? The magnification due to a spherical mirror is given by the ratio of the height of the image h2 to the height of the object h1. This tells us how large the image is as compared to the object. Formula: magnification capital M is equal to height of the image upon height of the object, which is equal to h2 upon h1. From this it can be shown that m is equal to minus v upon u. As the object is always kept above the principal axis, its height is always taken to be positive. For virtual images, the height is positive, while for real images, it is negative. As the object is kept on the left of the mirror, its distance u is always negative. Let us now revise Chapter 12, Study of Sound. What is sound? How is it produced? Sound is a form of energy which creates the sensation of hearing in our ears. It is produced due to vibrations of an object. What are longitudinal and transverse waves? Sound waves give rise to a chain of compression, which are places of higher density, and rarefaction, which are places of lower density, in the medium. The particles of the medium oscillate about their central or mean positions in a direction parallel to the propagation of the wave. Such waves are called longitudinal waves. On the other hand, in the waves created by dropping a stone in still water, the particles of water oscillate up and down. These oscillations are perpendicular to the direction of propagation of the wave. Such waves are called transverse waves. How does sound propagate? Can it travel through a vacuum? Sound propagates in the form of waves. A medium that is solid or liquid or gas is necessary for the propagation of sound waves. It cannot travel through vacuum. A sound wave can be shown in the form of a graph. At any moment during the propagation of a sound wave, we would find alternate bands of compression and rarefaction of the medium, that is, bands of greater and lesser density. The figure A shows the changes in density, while figure B shows the changes in pressure. The changes in density or pressure are shown in the form of a graph in figure C. The wavelength of sound waves is indicated by the Greek letter lambda, while its frequency is indicated by nu. The amplitude, which is the maximum value of pressure or density, is indicated by capital A. The time taken for one oscillation of pressure or density at a point in the medium is called the time period and is indicated by capital T. The value of frequency determines the pitch, that is high or low, of the sound, while the value of the amplitude determines its strength or loudness. What do you understand by velocity of sound? The distance covered by a point on the wave, for example, the point of highest density or the point of lowest density in unit time, is the velocity of the sound wave. Velocity is equal to distance upon time. Any point on the sound wave covers a distance equal to lambda, which is the wavelength, in time capital T, which is the time period. Thus, the velocity of sound is given by v is equal to nu into lambda, because 1 upon t is equal to nu, where nu is the frequency. Velocity is equal to wavelength upon time period, therefore v is equal to lambda upon capital T. Thus, the velocity of sound is equal to wavelength into frequency. What are audible, infra and ultrasound? The limits of hearing of the human ear are 20 Hz to 20,000 Hz. That is, the human ear can hear sounds of frequencies in this range. These sounds are called audible sounds. Our ears cannot hear sounds of frequencies lower than 20 Hz and higher than 20,000 Hz, that is 20 kilohertz. Sound with frequency smaller than 20 Hz is called infrasound. The sound produced by a pendulum and the sound generated by the vibrations of the Earth's crust just before an earthquake are examples of such sounds. Sound waves with frequency greater than 20 kilohertz are called ultrasound. What are the uses of ultrasonic sound? for communication between ships at sea, to join plastic surfaces together, to sterilize liquids like milk by killing the bacteria in it so that the milk keeps for a longer duration, that is, it lasts for a longer duration. Echocardiography, which studies heartbeats, is based on ultrasonic waves sonography technology. To obtain images of internal organs in a human body, in industry, to clean intricate parts, that is, delicate parts of machines where hands cannot reach, and to locate the cracks and faults in metal blocks. What is an echo? An echo is the repetition of the original sound because of reflection by some surface. In order to be able to hear the original sound and its reflection distinctly, that is clearly, at 22 degrees Celsius, the velocity of sound in air is 344 meters per second. Our brain retains a sound for 0.1 second. Thus, for us to be able to hear a distinct echo, the sound should take more than 0.1 second after starting from the source to get reflected and come back to us. Distance is equal to speed into time, which is equal to 344 meters per second into 0.1 second, which is equal to 34.4 meters. Thus, to be able to hear a distinct echo, the reflecting surface should be at a minimum distance of half of the above, that is 17.2 meters. What is reverberation? Sound waves get reflected from the walls and roof of a room multiple times. This causes a single sound to be heard not once but continuously. This is called reverberation. The time between successive reflections of a particular sound wave reaching us becomes smaller, and the reflected sounds get mixed up and produce a continuous sound of increased loudness which cannot be deciphered clearly. That is, which cannot be heard and understood clearly. This is the reason why some auditoriums or some particular seats in an auditorium have inferior sound reception. Sonar. Sonar is a short form for sound navigation and ranging. It is used to determine the direction, distance, and speed of an underwater object with the help of ultrasonic sound waves. Sonar has a transmitter and a receiver which are fitted on ships or boats. The transmitter produces and transmits ultrasonic sound waves. These waves travel through water, strike underwater objects, and get reflected by them. The reflected waves are received by the receiver on the ship. The receiver converts the ultrasonic sound into electrical signals, and these signals are properly interpreted. The time difference between transmission and reception is noted. This time and the velocity of sound in water give the distance from the ship of the object which reflects the waves. Sonar is used to determine the depth of the sea. It is also used to search underwater hills, valleys, submarines, icebergs, sunken ships, etc. What is sonography used for? Sonography technology uses ultrasonic sound waves to generate images of internal organs of the human body. This is useful in finding out the cause of swelling, infection, pain, etc. The condition of the heart, the state of the heart after a heart attack, as well as the growth of fetus inside the womb of a pregnant woman are studied using this technique.